So to solve this one out, you have to first, that 1/3 power changes, that means cube root. X squared plus 4x plus 6. Then to get rid of the cube root, you would go to the 3rd power to cancel it out. So 3 to the 3rd power is 27. So you have x squared plus 4x plus 6 equals 27. To solve it, you need everything on one side, so minus 27. And you get equal to 0. Now you can factor it. In order to solve it, you've got to factor. So come up with what multiplies to be negative 21, adds to be 4. Negative 3, positive 7. So since we need to solve that out, take it, x minus 3 equals 0, x plus 7 equals 0, and you're going to get your two answers, x equals 3, x equals negative 7. You should check these just to make sure that they work, that they're not extraneous, that they actually work when you plug them back in. So when you plug in 3 squared is 9, plus 4 times 3 is 12, plus 6. So that's 18, 27, and the cube root of 27 is 3, so that one works. And then just using some multiple choice strategies here, since there's not an option for 1 only, there's got to be 1 and 2. But if you check negative 7, that's going to work out also. You're going to get a 27 again inside here when you plug it in. So when you're graphing, you just got to remember that the parent function starts at 0, and then the square root of 1 is 1, square root of 4 is 2, and the square root of 9 would be up here at 3. So since that's the parent function, we can see that it's got to be shifted to the left 4 units. It's got to be shifted down 3 units. And then it's going the opposite direction. It's not going up, it's going down, which means it's also been reflected. So to challenge yourself a little bit more with this question, you could actually write the equation now that you know all that stuff. Since it was shifted left 4 units, left means plus inside the radical. Down means minus outside the radical. And since it was reflected over the x-axis, it's got to be a negative out in front. So if you can see the graph, you should also be able to take it back and write the equation of it also. This question didn't ask for it, but it's good practice. So the same idea is going on here. We can see that it was shifted to the right 3. It was shifted up 5. And again, it's going down, which means it was reflected. Again, same thing. If you want to challenge yourself a little bit, write that equation out. Reflected over the x means it was a negative out in front. Shifted to the right means x minus. And then shifted up 5 means plus 5 at the end. The plus 5 shifts it up 5, minus 3 shifts it right 3, and then the negative reflects. When you're solving with the square root, you isolate the square root first. This one's already isolated. Then you square both sides. When you square it, that means you got to multiply it by itself. And you have to FOIL, so x times x. And then negative 2 times x another negative 2 times x, and then negative 2 times negative 2 is positive 4. So we FOIL out the left side, we cancel out the square root on the right. Now to solve this, we need everything on one side, so let's get everything to the left. Negative 2, negative 2, and negative 1 makes negative 5x, and then 4 plus 2 is 6. So to solve this, we can factor two numbers that multiply to be positive 6 and add to be negative 5. For some reason, this seems like it's the hardest for high schoolers to factor. Could be 6 and 1, because 6 minus 1 would get you 5. But they can't multiply to be a positive and add to be a negative. If you did negative 6, positive 1, that multiplies to be a negative. So that's not it. So it's got to be both negative, and it's got to be 3 and 2. So then when you solve these out, you get x minus 3 equals 0, x minus 2. Solve them out, you get x equals 3, x equals 2. Then go back to the original problem and plug them in to make sure that they work out. They might not work out, which means it's extraneous. So let's check 2 and let's check 3. So when we plug in 2, 2 minus 2 equals square root of 2 minus 2. 0 equals the square root of 0, that's true. Then when we plug in 3, 3 minus 2 equals the square root of 3 minus 2. 1 equals square root of 1. That one's good also. They both work. Another one, pretty much the same. This one's a little bit easier. Isolate the square root. Square both sides. So we just get 9 equals 3x plus 3. Whoops. So subtract the 3. So we get 6 equals 3x. Divide. You get x equals 2. Plug it back in just to make sure. 3 times 2 is 6, plus 3. Square root of 9 is 3. That works. Same type of question. Square both sides to get rid of the square root. In this case, you have to FOIL because it was x minus 1 that you got to split. So I'll write it out. So when we FOIL this, when you multiply it, x times x, x times negative 1, negative 1 times x, and negative 1 times negative 1. So get everything on one side, subtract that x over, so we get x squared minus 3x, and then add the 1 plus 2. We're going to factor it. Multiply by 2, add to be negative 3. It's 1 and 2. They both need to be negative. Let's add a 2. Negative 1 times negative 2, and then negative 1 plus negative 2. So when you solve that out, you get x equals 1 and x equals 2. Plug those back in to make sure that it works. It's not extraneous. So plug in the 1. 1 minus 1 is 0. Equals square root of 1 minus 1 is 0. That's true. Plug in the 2. 2 minus 1 is 1. Square root of 1, that's also true. They both work. And yet another one. Same thing, square both sides because the square root's already isolated. We don't have to FOIL out, so it's a little bit easier. You still need to move everything to one side. That's x squared minus x minus 2 equals 0. And now factor it. Multiply to be negative 2. Add to be negative 1. That's minus 2 plus 1. Solve those. So you get x equals 2 and x equals negative 1. And then plug them back in to check to make sure if they are extraneous. So plug in the 2. 2 equals the square root of 4. That's true. Plug in the negative 1. You get negative 1 equals the square root of 1. That's not true. That's extraneous. So more like the graphing that we were doing a little bit ago. This minus, or this plus 2 means that we're actually shifting left 2. The minus 4 at the end means you're shifting down 4. So it's left 2, down 4. That's where we start this graph. And then you go through all your square roots. You know the square root of 1 is 1. The square root of 4, so you go 4 to the right, is 2. Go up 2. And then we know the square root of 9, so go 9 to the right. And the square root is 3, so you go up 3 from there. We get all of those coordinates. All you got to do is draw the curve. So there's the graph. To determine the domain, you got to remember domain is left to right. It's your x values, left to right. And the furthest to the left is over here at negative 2. And then when you're going to the right, it goes forever because you got an arrow going to the right. So it goes to infinity. Numbers in this case always will get the square bracket because there's always the point right there. For the range, it's low to high. You look for the lowest the graph goes. The lowest point on the graph is right there at negative 4. And again, the number gets the square bracket. The highest point has got the arrow that's going up, so it's going to infinity. The other thing that you should notice is that these numbers, the 2 and the 4, are the numbers in your domain and range. If you used a different number, you messed up somewhere. So this one, it shifts. It's got the minus 3, so that means right 3. And plus 1 means up 1. And then this negative makes it reflect down, reflect over the x-axis. So instead of starting here at 0, 0, it starts right 3 up 1 from there. Right 3 up 1. And that negative, all that means is that we go down instead of up when we're doing our square roots. So the square root of 1 is 1, but we go down 1 this time. The square root of 4, so we go 1, 2, 3, 4, is 2, so we go down 2. And then we're at the end of our graph, so just draw the curve. So our domain, which is left to right, the furthest point to the left is over here at 3. And then to the right, it has an arrow. It goes to infinity. Range is low to high. It has an arrow that goes down forever. So that means the lowest is negative infinity. The highest is right here, which is at 1. And your number always gets the bracket. When you graph a piecewise function, you have to know where it splits. This one splits at negative 3. So we're going to draw a straight line with a highlighter at negative 3. Just to remind us that that's where it splits. Then you can see that this less than symbol is pointing to the left. That means that this function, x minus 4, is on the left side. The greater than symbol points to the right, which means this function is on the right side. We also know that the square root function on the right has the line under it. It's the or equal to, which means that it gets the closed circle on the boundary line, that highlighted line. And the less than has an open circle because it is not equal to. So when you graph x minus 4, you start at negative 4 for your y-intercept. And the slope is 1, which means from there it goes up 1 over 1. You could do that the whole length of the graph. But what really matters is that you do it going to the left because we only want it on the left of our boundary line, so we got to work it that way. When you get to the boundary line, it has an open circle because it was not equal to. And you only keep the side of the boundary line that it's supposed to be on. So in this case, the left side. You only keep the left side of it, which is not very much. You can erase everything else. Then for your square root function, just like we practiced graphing a minute ago, this shifts left 3. It does not shift up or down at all. Left 3. We're on our boundary line. It gets a closed circle. Closed point. And then we know all of our square roots. The square root of 1 is 1, so we put a point there. Square root of 4 is 2, put a point there. Square root of 9 is 3, so you put a point there. And then that's all it's going to fit, so draw the curve. Same type of question here. This time we've got our boundary is going to be at 3. So we draw our boundary line at 3. And then on the left, we're doing x plus 2. And it's an open circle because it's not equal to. On the right, it's a closed circle. And it's square root of x minus 3. So if we started with the square root of x minus 3, that shifts to the right 3, which puts us at our boundary line with a closed circle. And then we know all of our square roots. The square root of 1 is 1. Square root of 4 is 2. That's all it fits. So draw your curve. And then for the left side, the line, square root, or it's x plus 2. So we start at our y-intercept of 2. The slope is 1, which means up 1 over 1. And when you get to the boundary line, when you reach the boundary line, you put an open circle. And you can continue that same slope going the other way, go to the left. When you're solving the system, you just have to set them equal to each other. So you set them equal to each other. You get 2 equals the square root 1 minus 4x. And then solve this just like we did a few problems ago. Isolate the square root. Square both sides. So you get 4 equals 1 minus 4x. And you're going to solve for x. So subtract the 1. And then you divide by negative 4. So you get x equals negative over negative turns positive 3 over 4. But this is supposed to be a positive 3, so that's supposed to be a negative answer here. It's negative 3/4. So when we plug that back in to get our y value that goes with it, we plug that in here, so that's 4 times negative 3/4. So that's 1 minus, well, negative times negative is positive. 4 times 3 is 12 over 4. 12 over 4 is 3. So you have 1 plus 3 inside the square root. So that's the square root of 4, which is 2. So our y value is 2. Our x value is negative 3/4. The y value is 2. That's what it was supposed to be. So our answer, you have to write as an ordered pair. Now, the other way that you can do this question without having to do it by hand, you can graph both of them. You can graph this as y1 and y2 on a graphing calculator. And then depending on what type of calculator you have, this depends on the buttons you have to push, but you're calculating the intersection. So if you type this in as y1, and when you do that, you have to do parentheses around everything. So you do square root parentheses 3x plus 1. So if you type these in as y1, y2, you then go to find the intersection. So on a Casio, the window has to show you where the lines cross, but then you can go G-solve, and you're finding the intersection. So you type them in as y1, y2, and then on Casio, you do G-solve intersection. And if you had a TI, it's pretty similar. You do the same thing, y1, y2, but then you have to go to calc. So you got to push the second button to get calc. And then you choose intersect. There's a few extra steps there with the TI, because you have to do a left bound and right bound and stuff. You need to know how to do that if that's your calculator. But either way, it'll give you the answer. Or you could solve it by hand like we did on number 47. When you solve this one out, you get x is 5, y is 4, so it's the point 54. So this question is similar to those that we were doing a little while ago, or kind of like solving that last problem by hand. You isolate the square root and square both sides. So step 1. Step 2, you got to square both sides. So you can see the square root is now gone. And you square out both sides. When you FOIL n minus 7, n minus 7, and combine like terms, this is what you get. So that step is good. Step 3, they got to move everything over. So minus 31, that is 18, plus 3n, that'd be negative 11, so that's good. Then we have to factor. Negative 9, negative 2. That's factored correctly. So we get n equals 9 and n equals 2. That's correct. Are they done? Are they? The only thing that they need to maybe do is check to see if those are extraneous. So you do need to go back, plug them in. So the only possible mistake here is maybe they didn't check for extraneous. So plug in 9. That's 31 minus 3 times 9 is 27. So that's the square root of 4 is 2. That is correct. 9 works. When you plug in the 2, you get 31 minus 6, which is 25, equals 2 minus 7, which is negative 5. That does not work. So is the solution right? Not quite. N equals 2 is extraneous. So same thing here. Square both sides. Negative 17 plus 6n. Multiply that out. That's correct also. Get everything to one side. So add the 17 over, you get 33. Subtract the 6n, you get negative 14. That's correct. Negative 11 and negative 3, that's factored correctly. N equals 11, n equals 3, that's correct. Then they went and they did check for an extraneous, it looks like. So it looks like 3 does not work here. Because you would get a negative 1 on the right and a positive 1 on the left. So are they correct? Yes.